Hi everyone, this video is about my own summary for chapter 11, and this chapter was entitled as Build a Small Network. So watch this. So this chapter is about build a small network. So there's a lot of businesses that the majority of businesses are small. It is not surprising that the majority of the networks are also small. With small networks, the design of a network is usually simple. The number and type of devices included are significantly reduced compared to that of a larger network. The network topologies typically involve a single router and one or more switches. Small networks may also have wireless access points, possibly built into the router and IP phones. As for connection to the internet, normally a small network has a single WAN connection provided by the DSL cable or an Ethernet connection. So managing a small network requires many of the same skills as those required for managing a larger one. The majority of work is focused on maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. In order to meet the user requirements, even the small networks, it requires planning and designing. Planning ensures that all requirements, cost factors, and deployment options are given due considerations. When implementing a small network, one of the first design considerations is the type of intermediate device to use to support the network. When selecting the type of intermediate devices, there are a number of factors that need to be considered. So the cost of switch or router is determined by its capacity and features. Choosing the number and type of ports on a router or a switch is a critical decision. Newer computers have a built-in 1 GB NICs or the network interface cards and 10 GB ports that are already included with some workstation and servers. While it is more expensive, choosing layer 2 devices that can accommodate increased speeds allows the network to evolve without replacing central devices. Networking devices come in both fixed and modular physical configurations. Fixed configurations have a specific number and type of ports or interfaces. Modular devices have expansion slots that provide the flexibility to add new modules as requirements evolve. So care must be taken to select the appropriate modules and interfaces for the specific media. All hosts within an internetwork must have a unique address when implementing a small network. It is necessary to plan the IP addressing space. The IP addressing scheme should be planned, documented, and maintained based on the type of device receiving the address. Planning and documenting the IP addressing scheme helps the administrator track device types. This can be very useful when troubleshooting network traffic issues using a protocol analyzer. So additional to this, administrators are better able to control access to resources on the network based on the IP address when a deterministic IP addressing scheme is used. So this can be especially important for hosts that provide resources to the internal network as well as to the external network. So a failure of a network can be very costly. In order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps to eliminate single points of failure. There are many ways to accomplish a redundancy in a network. Redundancy can be accomplished by installing duplicate equipment, but it can also be accomplished by supplying duplicate network links for critical areas. The network administrator should consider the various types of traffic and their treatment in the network design. The routers and switches in a small network should be configured to support the real-time traffic, such as the voice and the video, in a distinct manner relative to other data traffic. The network is only as useful as the applications that are on it. There are two forms of software programs or processes that provide access to the network. This is the network applications and the application layer services. So when we say network applications, these are the software programs that is used to communicate over the network. Some end-user applications are network aware, meaning that they implement application layer protocols and are able to communicate directly with the lower layers of the protocol stack. Email clients and web browsers are examples of this type of application. But when we say application layer services, this is where the other programs may need the assistance of application layer services that is use network resources like the file transfer or the network prints pooling. Though transparent to an employee, these services are the programs that interface with the network and prepare the data for transfer. Different types of data, whether text, graphics, or video, it require different network services to ensure that they are properly prepared for processing by the functions occurring at the lower layers of the OSI model. So, the businesses today are increasingly using IP telephony and streaming media to communicate with customers and business partners. The network administrator must ensure the proper equipment is installed in the network and that the network devices are configured to ensure priority delivery. So, to ensure the existing and proposed real-time applications, the infrastructure must accommodate the characteristics of each type of traffic. So, the network designer must determine whether the existing switches and cabling can support the traffic that will be added to the network. So, the voice IP or the VoIP devices convert an analog into a digital IP packets. The device could be an analog telephone adapter, or which is also called the ATA or ATA, that is attached between a traditional analog phone and the Ethernet switch. So the voice IP is much less expensive than an integrated IP telephony solution, but the quality of communications does not meet the same standards. So voice and video over the IP solutions for a small businesses can be realized. The IP phone itself performs voice to IP conversion. Voice-enabled routers are not required within a network with an integrated IP telephony solution. So, IP phones use a dedicated server for call control and signaling. To transport streaming media effectively, the network must be able to support applications that require delay-sensitive delivery. The network administrator has an enough lead time to make intelligent decisions about the growing the network in line with the growth of the company. To scale a network, several elements are required. These are the network documentation, which is the physical and the logical topology. Next is the device inventory, that is the list of devices that use or comprise the network. But, and the next is the budget that itemize IT budget, including the fiscal year equipment purchasing budget, and lastly is the traffic analysis, which is the protocols, the applications and services, and the respective traffic requirements. It should be documented. So when trying to determine how to manage network traffic, especially as the network grows, it is important to understand the type of traffic that is crossing the network as well as the current traffic flow. If the types of traffic are unknown, a protocol analyzer will help identify the traffic and its source. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic and its source, as well as the type of traffic being sent. This analysis can be used to make decisions on how to manage the traffic more efficiently. This can be done by reducing unnecessary traffic flows or changing flow patterns altogether by moving a server. A network administrator must also be aware of how network use is changing. A small network administrator has the ability to obtain in persons snapshots of employee application utilization for a significant portion of the employee workforce over time. So, there are different types of threats. Whether a wired or a wireless, computer networks are essential to everyday activities. So, individuals and organizations alike depend on their computers and networks. Interruption by an unauthorized person can result in costly network outages and loss of work. Attacks on a network can be upsetting and can result in loss of time and money due to the damage or theft of important informations or assets. Intruders can gain access to a network through software vulnerabilities, hardware attacks, or through guessing someone's username and password. Intruders will gain access by modifying software or exploiting software vulnerabilities are often called hackers. After the hacker gains access to the network, there are 4 types of threats that may arise. It may be identity theft, information theft, disruption of service, and data loss and manipulation. So, an equally important vulnerability is the physical security of devices. An attacker can deny the use of network resources if those resources can be physically compromised. So, the 4 classes of physical threats are hardware threats, which is the physical damage to servers, routers, switches, and cabling plant and the workstations. Next is the environmental threats. These are the temperature extremes, too hot or too cold, or humidity extremes, too wet or too dry. Next is the electrical threats, that is voltage spikes, insufficient supply voltage or brownouts, unconditioned power or noise, and the total power loss. And lastly is the maintenance threats. These are the poor handling of key electrical components or the electrostatic discharge. Next is the lack of critical spare parts, poor cabling, and poor labeling. So these issues must be distributed within an organizational policy. So, vulnerability is the degree of weakness which is inherent in every network and device. This includes routers, switches, desktops, servers, and even security devices. Typically, the network devices under an attack are the endpoints, such as the servers and the desktop computers. Malware or malicious code is short for the malicious software. It is code or software that is specifically designed to damage, disrupt, steal, or inflict or illegitimate action on data, hosts, or networks. The viruses, the worms, and the Trojan horses are type of malware. So a computer virus is a type of malware that propagates by inserting a copy of itself into and becoming part of another program. It spreads from one computer to another, leaving infections as it travels. So viruses can range in severity from causing mildly annoying effects to damaging data or software and causing a denial of service or the DOS conditions. Almost all viruses are attached to an executable file. So which means the virus may exist on a system but will not be active or able to spread until a user runs or opens the malicious host file or a program. So, viruses spread when the software or document they are attached to is transferred from one computer to another, using the network, a disk, a file sharing, or an infected email attachments. So, computer worms are similar to the viruses in that they replicate functional copies of themselves and can cause the same type of damage. It is also possible for networks to fall prey to various network attacks. Network attacks can be classified into three major categories. These are the reconnaissance attacks, which is the discovery and mapping of systems, services, or vulnerabilities. Access attacks, where the unauthorized manipulation of data, system access, or user privileges, and last is the denial of service is the disabling or corruption of networks, system, or services. Access attacks exploit that is known as the vulnerabilities in authentication services. So while the denial of service attacks are the most publicized form of attack and also among the most difficult to eliminate, even within the attacker community, the DOS or the denial of service attacks are regarded as trivial and considered bad form because they are require so little effort to execute. But because of their ease of implementation and potential significant damage, the DOS attacks deserve special attention from the security administrators. So to help prevent the denial of service attacks, it is important to stay up to date with the latest security updates for operating systems and applications. To protect network devices, it is important to use a strong passwords. Strong passwords are only as useful as they are secret. There are several steps that can be taken to help ensure that the passwords remain secret. Using the global configuration command or in the service password encryption, it prevents unauthorized individuals from viewing passwords in plain text in the configuration file. So this command causes the encryption of all passwords that are unencrypted. Telnet is not secure. Data contained within a Telnet packet is transmitted unencrypted. For this reason, it is highly recommended to enable the SSH or the secure shell on devices for secure remote access. It is possible to configure a Cisco device to support the SSH using 4 steps. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. Creating an effective network performance baseline is accomplished over a period of time. So design as a variation of the traceroute command, the extended traceroute command allows the administrator to adjust parameters that is related to the command operation. This is helpful when troubleshooting routing loops, determining the exact next hop router, or to help determine where packets are getting dropped by a router or denied by a firewall. While the extended ping command can be used to determine the type of connectivity problem, the extended traceroute command is useful in locating the problem. So the Cisco IOS CLI show commands, it display relevant information about the configuration and operation of the device. The show commands are available whether the device was configured using the CLI or Cisco Configuration Professional. The IP address of the default gateway of a host can be viewed by issuing the ipconfig command at the command line of a Windows computer. So use the ipconfig all command to view the MAC address as well as the number of details regarding the layer 3 addressing of the device. Next is the ARP command that is executed from the Windows command prompt. The ARP is a command list all devices currently in the ARP cache of the host, which includes the IPv4 address, the physical address, and the type of addressing, whether it is a static or a dynamic for each device. So there are several other iOS commands that are useful. iOS process, protocols, mechanisms, and events generate messages to communicate their status. These messages can provide valuable information when troubleshooting or verifying system operations. The iOS debug command allows the administrator to display these messages in a real time for analysis. It is a very important tool for monitoring events on a Cisco iOS device. Connections to grant access to the iOS command line interface can be established locally or remotely. Local connections require physical access to the router or a switch. Therefore, a cable connection is required. Remote connections are established over the network. Therefore, they require a network protocol such as an IP. No direct physical access is required for the remote sessions or remote connections. So, if the communications are restricted to the exchange of data in one direction at a time, this connection is called a half duplex. Full duplex allows the sending and receiving of data to happen simultaneously. Duplex mismatches may be difficult to troubleshoot as communication between devices still occurs. A duplex mismatch may not become apparent even when using tools such as the ping. IP address related problems will likely keep remote network devices from communicating because IP addresses are hierarchical. Any IP address assigned to a network device must conform to that network's range of addresses. Wrongly assigned IP addresses can create a variety of issues, including the IP address conflicts and routing problems. The OSTN devices are configured to rely on a DHCP server for automatic IPv4 address assignment. If the device is unable to communicate with the DHCP server, then the server cannot assign an IPv4 address for the specific network, and the device will not be able to communicate. So the default gateway for an end device is the closest networking device that can forward traffic to the other network. So that's all, and thank you for watching this video. I hope you enjoy and you understand my video. So thank you for watching this. I'm Kisha Lyka Villanueva of IT 2105.